Chapter 8 Chemical Equilibrium 8.1 Dynamic Equilibrium Part 1. At the end of the lesson, students should be able to first, explain a reversible reaction. Second, state the characteristic of a dynamic equilibrium system and law of mass action or law of chemical equilibrium. Irreversible reaction. The reaction in which products cannot be reconverted into starting material reactant are called as irreversible reactions. Examples of irreversible reaction: the burning of magnesium in the air. Magnesium ribbon is burned in the presence of oxygen to give magnesium oxide. Amount of magnesium decreases with time. No more magnesium left when reaction is completed. While magnesium oxide produced when the reaction is completed. The reaction of silver nitrate with sodium chloride. Silver nitrate is added to sodium chloride to give silver chloride and sodium nitrate. For irreversible reaction, the reaction will go to completion, and it is represented by a line with an arrowhead showing that reaction proceeds in only one direction. Graph of concentration versus time for irreversible reaction. Reactant A produces product B shows that amount of reactant A will decrease with time, while amount of product B will increase, and in the end, only product B is present in the vessel. Some of general examples of irreversible reaction are water flowing down the hill and heat flowing from a hot body to cold body. In real life, not all chemical reactions can go to completion to form product. In fact, many chemical reactions cannot go to completion. Reversible reaction. The reaction that cannot go to completion, where the chemical reactions can take place, involve forward and reverse directions. For reversible reactions, an equilibrium can be formed sometimes after the reaction. The equilibrium formed is called a dynamic equilibrium. Dynamic equilibrium has a few characteristics. The first one, the concentrations of the reactants and products remain unchanged at equilibrium. Second, the rate of forward reaction is equals to the rate of reverse reaction. Here is example of reversible reaction. Production of ammonia from hydrogen and nitrogen. Some hydrogen react with nitrogen gases to form ammonia. This reaction is denoted by a double arrow pointing both direction in a chemical equation indicate that the reaction proceeds in both directions at one time. The formed product, ammonia, can revert or go back to their original reactants, hydrogen and nitrogen. At equilibrium, fixed amount of reactants, hydrogen and nitrogen, and product, ammonia, are present in the reaction vessel. Both product and reactant exist when chemical equilibrium is established. For a reversible reaction at equilibrium and constant temperature, a certain ratio of reactant and product concentration has a constant value K, equilibrium constant. Here is a chemical reaction that written generically just A plus B goes to C plus D, and the small letter A, B, C and D to represent the stoichiometric coefficients. At equilibrium, the equilibrium constant K equals to concentration products C power of its coefficient C times concentration D power of its coefficient D over concentration reactants A power of its coefficient A times concentration B power of its coefficient B. As a conclusion, chemical reactions can be either reversible or irreversible reactions. Dynamic equilibrium exists in reversible reactions. The main properties of dynamic equilibrium are: first, rate of forward equals to rate of reverse reactions. Second, the concentration product and concentration reactant are constant at constant temperature, but the reaction do not stop. According to law of mass action, for a reversible reaction at equilibrium and constant temperature, the ratio of concentration reactant and concentration product has a constant value K.